All right, so today we're going to start into chapter 5.4, and 5.4 talks about isosceles triangles and equilateral triangles. So hopefully you remember that an isosceles triangle is a triangle that has two congruent sides. So the two congruent sides, those are called the legs. So in your triangle to the right here, that triangle ABC, that's a leg and that's a leg. And then the angle where the legs intersect, this is called the vertex angle. So that angle 1 right there is a vertex angle. And then the side opposite the vertex angle, this bottom side, is called your base. Lastly, you have the angles along the base. Those are called the base angles. So the angle 2 and angle 3, those are your base angles. And so now the isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So for example, if you have the length AB is congruent to CB, then the measure of angle A is this congruent to angle C. So if AB and CB are congruent, then angle A and angle C are also congruent. So look at that triangle above, and you can see that angle 2 and angle 3 are congruent because the two legs are congruent. So the converse of the isosceles triangle theorem is if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So it's kind of just like the backwards version. So if you have angle A and angle C are congruent, then the length AB is congruent to CB. All right, so let's do a couple examples here. So I'm looking at number 1, and the little tick marks on the side tell me that those two side lengths are the same. And so because of that, this angle should be 68. I don't know why it cuts off some of my writing, but just know that that should be a 68. And so angle J is 68. So then we know that since the interior angles of a triangle should add up to 180 degrees, we know that 68 plus angle K should add up to 180 degrees. So if we solve for K, we can find that K equals 44 degrees. So we'll fill those in. And now we know for number 2, we know the vertex angle, and we also know that those two legs are congruent. So that means that angle C and angle E would have to be the same measurement. So what I did is subtract 106 from 180 and then just divide that measurement by 2. So I got 37 for both of those angles. All right, so what I want you to do now is go ahead and pause the video and try this next one on your own. All right, so hopefully you pause the video and you found that YZ is 12 centimeters. And then in order to find the angle of Y, I just added up 77 plus 77 plus Y equals 180 and solved for Y, and I got 26 degrees. All right, so let's step it up a notch. So for 4, I need to find the value of each variable. So I'm looking for the value of X. And I know that since it's an isosceles triangle, because those tick marks are there on the sides, that those two angles are the same. So what I can do is set those equal to each other. So that should be a 5x plus 9 equals 8x minus 30. Still don't know why it cuts it off sometimes, but it does. And then if you solve for x, you should get 9 equals 3x minus 30, and then you should get 39 equals 3x, and then divide by 3 on both sides and get x equals 13, or 13 equals x. Okay, so now what I want you to do is pause the video, try the next couple on your own, and we'll see what you get. All right, so hopefully you pause the video, and for number 5, hopefully you set them equal to each other because those angles are congruent on an isosceles triangle. You solved for x, and you got 8 equals x. For number 6, you know again that those two sides are equal. So now we're talking about side lengths instead of angles, but we know that those two side lengths are equal because those two angles are equal. And so you set them equal to each other, solved for x, and got x equals 3. All right, last one. Let's do this one together. So we're solving again for x here, and we know that those two angles are the same measurement, so then those two side lengths are the same. So we'll set them equal to each other and solve for x, and you should get x equals 16. All right. So moving on to equilateral triangles. A triangle is equilateral if and only if it is equiangular. It's a very hard word to say. So if you know that measure of angle A equals measure of angle B, which equals measure of angle C, then you know that all the side lengths are the same, so AB equals BC equals AC. And then vice versa, if you know that all the side lengths are the same, then you know that all the measurements for the angles are the same as well. And if each angle is the same measurement, then you would just take 180 and divide it by 3, and you'd get 60 for each measurement on the inside. So every angle in an equilateral triangle is 60 degrees. So if I'm looking at 11, I want to find each missing measure. So I'm going to start with measure of angle C. Since I know that 2 of them have 60 degrees as their angle measurement, then I know the third one is 60 degrees. And then because every angle on the inside is 60 degrees, that means it is an equiangular triangle. So that means it is also equilateral. So then every other side length should be 9 feet. Okay, go ahead and try this next one on your own. All right, so hopefully you tried this one on your own, and you know that because those little tick marks on the side tell you that all 3 sides are equal, then all of the angles should be equal, and they should all be 60 degrees. Okay, last one. This one is a little bit of a challenge here. So you want to solve for x and you want to solve for y. So let's just take a look at this triangle so far. We know the angle has to be 60 degrees if it is a equilateral triangle. And we know that it's an equilateral triangle because it tells us that. So the first thing I did is I set 7x minus 3 equal to 60. So there is another way that you can do this that I can show you in a second. So I'm going to solve for x first. And so when you solve for x, you should get x equals 9. So then now if you're looking at the side lengths, you have all y variables in those side lengths. And since you know that it's an equilateral triangle, you know that each one of those sides has to be equal to each other. So you can just take 2 side lengths and set them equal to each other. So I did 14y minus 59 equals 11y minus 23. Solve for y, and you should get y equals 12. All right. Please also remember that I have office hours that no one ever comes to on Monday and Fridays from 11 to 12. If you follow the Google Meet link that's posted on Google Classroom, it'll take you straight there. And you can drop in at any time during those hours, and I will be there.